Okay, let's see. Looks like we're capturing sound and video, so that should be good. Check here. Looks like that's working too. So, I guess I should keep this chat window available. Or maybe this chat window available? Or I can just check it every so often. Okay. So, let's talk about college algebra. And if you have questions about calculus, if you're from the calculus class, then um, I will answer those questions as I see them in chat. Let's talk about, I think we did Form A in class, so let's look at Form C problems. Here's our formula sheet that you will get on the exam. And here are some problems from a couple years ago. The finals are always pretty similar, um, although they won't have exactly the same questions. They will be similar. Let's see. Mm, Here we go. We have a little canvas to write on. Make sure not to mess up our background. Okay. So find the difference quotient. This is the difference quotient formula. And simplify for the function f of x equals x squared plus 3. So here we go. So this is the difference formula, f of x plus h minus f of x over h. And if we plug in f, we're told that f of x equals x squared plus 3. So that means that f of x is x squared plus 3. We're just substituting this here is f of x, so we plug in f of x there. H still stays on the bottom of our fraction. We erase the mark that doesn't deserve to be there. And then we need to plug in f of x plus h. So what that means is that everywhere that we see an x in the original equation, we're going to replace it with x plus h instead. So instead of x squared, it's x plus h squared. And then, so x turns into x plus h. So x squared turns into x plus h squared. The plus 3 stays as it is. Here is the difference quotient with those values plugged in. For this problem, we're usually expected to simplify the expression. Simplification, like in this case, means you need to cancel this h out of the bottom of the fraction. It always will factor out of the top, and then you can cancel it with the bottom. So we are done when we can cancel that h from the top and bottom of the fraction. Let's simplify. We get x squared plus 2hx plus h squared minus 3 minus x squared minus 3. That's done by distributing this negative sign. Oops. And also multiplying out this binomial. We still have an h on the bottom, so we're not done yet, but we've multiplied that out. We can gather our like terms. The x squareds cancel. The 3's also cancel. So what we're left with after these cancellations, x squared with x squared, negative 3 with negative, sorry, that should say positive 3. So let's put a plus sign in the 3 that we're canceling out. That leaves us with 2hx plus h squared over h. We factor the h out of the top. That gives us h times 2x plus h. We'll get that drawn a little bit nicer. Here's our plus sign, and here's our h. Over h, which cancel, and that leaves us with equals 2x plus h. This is considered the final answer because we've canceled the h out. Okay, let's see if we have any comments. We have, why is it x plus h squared plus 3 instead of x squared plus 3 plus h? That's a great question. So it's because we're doing f of x plus h like this. We'll move this over here, I guess. Okay. Well, that's not going to line up nicely for me. Okay. So x plus h is in the inside, just like if I had f of 2, then everywhere that I see an x in the original expression, I'm going to replace it with a 2. So that would be, this equals 2 squared plus h. If I have f of x plus 2, that becomes x plus 2 squared plus h. And if I have f of x plus h, that's the same idea as this x plus 2, but instead of a 2, I have a second variable h. I'm sorry, I shouldn't have had an h. Our equation was x squared plus 3. So let's make that a 3. There we go. So the h is on the inside of these parentheses, and that means that the h will be on the inside of any powers or multiplications that we do. Like that. My computer is a little aggressive on scrolling when I get near the edge of the screen. Okay. Let's move on to another question, unless we have more questions about this. So, we have f of x equals 5 over 4 x minus 12. We're told this is 1 to 1, which means it's invertible. And we're told to find an equation of the inverse function. The way to find an inverse function is you're going to take this y here, this is a y, and you're going to take the x and you're going to switch them. Every x turns into a y, every y turns into an x, and then you just solve for y. So x equals 5 over 4y minus 12. We want to solve for y. The best way to do that is going to be to multiply by the denominator. This gives us x times 4y minus 12 equals 5. We distribute 4x y minus 12x equals 5. Everything that doesn't have a y moves to the other side. 4x y equals 12x plus 5. And then we divide by the coefficient on y. Y equals 12x plus 5 divided by 4x. And that is our inverse function. Let's look over here. Neat. Okay, let's keep going. So, we have this polynomial, and we're told to find all possible rational roots. That's half the points, and then find the actual roots as the rest of the points. So, let's do that as well. So, our polynomial is x to the fourth plus x to the third minus 11x squared minus 5x plus 6. And so our coefficient on our leading term is 1. Our coefficient, our constant is 6. So what we do is we set up a number sieve, setting all of the factors of the constant across the top. So 1, -1, 2, -2, 3, -3, 6, -6. And we take all of the factors of our leading coefficient, which is just 1, and we take each of these factors of our constant and divide it by each of the factors of our leading coefficient. And when we've done that, these will be our potential roots. Fortunately for us, we only have the one row because the only positive factors of 1 are, well, 1 is the only positive factor of 1. So these are the numbers we have to check. So we set up our synthetic division, and I'm going to delete this extra space here. So synthetic division, we have our coefficients. We have 1x to the fourth, 1x to the third, negative 11x squared, negative 5x, and 6. And we should make sure that we have, like, when we're setting it up, if there happens to be a term that's skipped, then we have to put a 0 in as a placeholder in our synthetic division. So we don't have that, but like if it had just gone like x to the fourth and then skipped to like x squared without having an x to the third term, we would need to put a 0 in this location to cover up for that. Let's try our first possible root. Let's try 1. So we go 1 times 1 is 1, 1 plus 1 is 2, 1 times 2 is 2, 2 minus 11 is -9, times 1 is -9, plus 5, -5 is -14, -14, -8. The last number was not 0, so this was not an actual root, so we keep going with the original numbers like this. We try our next root, which is -1. I'll put my colors over there. That's good. 1 times -1 is -1. That gives us 0. That gives us 0. That gives us -11, +11, 6, -6, and 0. Make the 6 look better. That is a root. So let's make a list of roots. Should have saved some space for that. Put it here. Roots. We have -1. Okay. Now that we've done that, since we got a 0, we need to reevaluate, are any of our potential roots in our number sieve up here, these numbers, are any of them no longer possible? Well, our constant is 6, our leading coefficient is 1, so our factors of 6 are still here, and our factors of 1 is still here. So that didn't do that didn't reduce the size of the number sieve. We did check 1, so we can cross that off the list. And it would be good for us to check -1 again to see if it's a double root. So let's do that. Since we had a success, we use the bottom line as our new polynomial for our synthetic division. 1, -1, -1, 1, -10, 10, and 16. That didn't work. Come up here. We'll cross off -1. It's no longer a root. We'll copy the most recent line that worked. 1, 0, -11, 6. And we go to our next possible root, 2. 1, 2, 2, 4, -7, -14, -8. That didn't work. We'll cross off -2. Sorry, we'll cross off +2, and we'll set up -2 as our next root. 1, 0, -11, 6. We go again. 1, -2, -2, +4, -7, +14, and 20. So that didn't work either. Okay. Checking the chat. Let's try again. 1, 0, -11, 6. 1, 0, -11, 6. Okay, let's try 3. 1, 3, 3, 9, -2, -6, 0. So 3 worked, so let's add that to our list of roots. Our constant changed. This changed. It was -6 and now it's -2. So that means that we have to go back up to our number sieve and say, any of these numbers that doesn't divide 2 gets deleted. So we cross off that one, and that one, and that one, and that one, because none of those divide 2. So looking at this here, oh, and none of these work because we already checked them. So there are no more numbers on our number sieve. I guess I should stick to the underlines so that the number sieve is still readable. But fortunately, this is a quadratic. So I can use the quadratic equation on that to finish solving. I have x equals negative b plus or minus the square root of b squared minus 4 times a times c. So that's negative 4 times 1 is negative 4 times negative 2 gives us positive 8. Negative 4 times negative 2 is positive 8. And then we divide this by 2 times a, but a is 1, so that's just 2. So we get this. So x equals negative 3 plus or minus the square root of 17 over 2. And this gives us 2 more roots to our polynomial that we can add onto our list. And since we started with a degree 4 polynomial, there are only 4 roots. So here are 2 of them, and the quadratic formula gave us 2 more. Those are, let me check, negative 3 plus or minus the square root of 17 over 2. These are all 4 of the roots, because one is with the positive sign, and one is with the negative sign. Okay. Well, those are long questions. The rational roots theorem ones are long. If you use Descartes' law of signs, you can sometimes shave off some of the numbers from the number sieve. And if you remember the upper bound and lower bound theorems, then those can shave off some time as well. But they are just a little bit long. Okay. Graph the rational function. We have this rational function, y equals 4 over x squared minus 4. So the first thing we have to do when we're graphing a rational function is we want to factor the top and bottom. Top is already factored, it's 4. But our denominator factors as x plus 2 times x minus 2. Factors of the top give us roots of the function. Factors of the bottom give us asymptotes of the function. So what we know just from this factoring is that we have a factor at, we have an asymptote at positive 2. That comes from this factor, because the signs flip. And we have an asymptote at negative 2, and that comes from this factor, again, because the signs flip between the location of the asymptote and the number in the factor that represents it. Okay. The next thing we notice is that we have no roots because there are no values of x that make the numerator 0. 4 is never 0, at least in this class. So no roots, just vertical asymptotes. The horizontal asymptote, well, because this has a higher degree in the denominator than the numerator, we have a horizontal asymptote at 0. So let's put our little dotted line there. And the last thing we're going to need are the last thing we're going to need is the y-intercept. So we plug in 0 for x to find that. When I plug in 0 for x, I get 4 over -4. So that's -1, so that's down here. And from that point, we will start graphing. So I'm negative, I'm headed to an asymptote. That means I curve down to -infinity. I see what's the power on the factor that goes with that asymptote. It's 1, right here is 1. Odd means we change sign, so we were negative, now we will be positive. We come down from infinity and go toward the horizontal asymptote. On the other side, we're negative, we're going to an asymptote, so we go down to -infinity. The power on that factor is also odd, so we switch signs, and we come down from infinity and go toward the horizontal asymptote. And this is the rough graph of our function. Okay. Solve a logarithmic equation. With those, the two ways to do it are either to combine all the logs on both sides so that you have log of something equals log of something else, or if you don't have everything in logs and can't combine everything that way, you combine all the logs on one side together and you have them set equal to a number on the other side. So in this case, we're going to have the second situation where we're trying to get it to be the log base 2 of something equals a number. That's the goal. I'm going to take a drink. Okay, so we have the log base 2 I used to have a tablet, but it doesn't work anymore. So now I'm doing this on mouse. It makes all the words bad looking. Need to get a new tablet. Okay, so we have this log base 2 of x plus log base 2 of x minus 1 equals 1. Since the logs are the same base, we can combine by multiplying the arguments. That gives us log base 2 of x times x minus 1 is x squared minus x equals 1. We can cancel these by going 2 to the log base 2 equals 2 to the 1. That means those cancel. I get x squared minus x equals 2 to the 1 is 2. Pull that over to the same side. I now have a quadratic. I can solve with the quadratic equation, or if I can factor easily, I can do that. This one does factor easily. We get x minus 2 times x plus 1. So our solutions are 2 or -1. But this is a logarithmic equation, so we go back to the original statement and say, can I plug 2 into the original equation? Well, that works, and 2 minus 1 is 1, so that works. Everything's great. Can I plug -1 in? Oh no, can't take a log of a negative. That's bad. So this is extraneous, and this one is an actual solution. Okay. If $3,000 is invested at an annual interest rate of 4% compounded continuously, how much time will it take for the investment to increase in value to $7,000? And then it gives you these two equations. So we have to know which one to use. And maybe I need to make this bigger so people can see. So, which of these two equations should we use? Anyone know? It's okay. Um, so this equation, this is called the discrete compound interest equation, and I can blow it up a little bit bigger so you can see. This is discrete compound interest. What that means is that in this equation, interest is only charged a certain number of times per year. That can be a high number, like once a day, which is how banks loan each other money, or it can be a more normal number, like 12. Most banks will charge interest once per month on mortgages, or they'll award interest once per month on things like savings accounts or CDs. The other equation is called continuous compound interest. This is the continuous compound interest equation, and it represents interest being charged instantaneously. So, like, not once a month or once a day, but, and not even like once a second, but like faster than that, all the time, never stopping. And so, this is the hypothetical, like, for any set amount of time, any set principal, and any set interest rate, the um, the continuous compound interest represents the fastest that the money could possibly grow in a compound interest situation. So, yeah, if we have $3,000 invested, so principal is 3,000. Change the color back to black. So principal equals 3,000. Interest rate is 4%, which we need to remember to convert to a decimal. Compounded continuously means that we don't have an n value. That's a discrete thing only. How much time will it take for the investment to increase in value to 7,000? So we want the balance on the account. I don't know why balance is A, but it is. Maybe A for account. But we want to know when the balance is equal to 7,000. So that means we plug these into the continuous equation, which is A equals P e to the RT. So we have 7,000 equals 3,000 times e to the 0.04 t. Now, in this class, you can reasonably be expected to solve for A, for P, or for T. It's even possible to solve for R, but that is a rarer thing. Especially like because you can only solve for R if the n times the t is a low enough value that you can use your like rational roots theorem in a reasonable amount of time to do it. So it's not you're not going to be asked to solve for R. You will definitely not be asked to solve for N. Both of those would be kind of out of the scope of the class, kind of too hard to get. But you should practice solving for A, for P, and for T in all of these situations because the question could come in for any of those three things, A, P, and T. And you should practice for both the compound continuous interest, which is what we're doing here, or the compound discrete interest, which I guess we can do if the chat asks for it. But we plug these in and we solve for T. First step to do is to divide by 3,000. So we get 7 over 3 after we cancel the thousands equals e to the 0.04t. We take the natural log of both sides. ln of 7/3 equals 0.04t. And we divide by 0.04. T equals the natural log of 7/3 divided by 0.04. And there's our answer. We could plug that into a calculator to get a decimal. In fact, we might as well. Let's plug that into a calculator. So we have, let's see how this calculate. This calculator is not the great type. So with this calculator, I have to type in 7 divided by 3 first. Hit equals, I get this. Then I hit the natural log. And I get that. And then I'm going to divide by 0.04. You should make sure to know how your calculator processes things. This is the bad way for the calculator to process things. So anyway, this gives us 21 years. So this investment will grow from 3,000 to 7,000 in 21 years. Well, and a little bit. Okay. Solve the system of equations using elimination or substitution. This one, I'm going to choose elimination. So we have x minus y equals -1, and we have negative x plus y squared equals 3. Adding together, we get the x's cancel, we get y squared minus y equals 2. Move the 2 to the same side, y squared minus y minus 2 equals 0. And from here, this factors as not x, y minus 2 times y minus 1, no, plus 1 equals 0. This seems familiar. I think that we already factored that polynomial. X minus 2, x plus 1, y minus 2, y plus 1. Yeah, it's the same polynomial. They just swapped it for y. Okay. So we know the y values that we can get are y equals 2 or y equals -1. And we plug that into one of the two equations. I think that we should plug it into the top equation because that is gonna be easier than plugging it into the bottom equation. So we get x minus y equals 1. That's the same as x equals y minus 1. So x equals 2 minus 1, 1, and x equals -1 minus 1, which is -2. So that means that we have the point 1, comma 2, and the point -2, comma -1. These are the 2 points where these cross. So we have a parabola that opens sideways and a line that cuts across the parabola and hits it in these 2 points. If we want to check these answers, we can use Desmos. Desmos is really nice for practicing graphing. So we have our two equations are x minus y equals -1, and negative x plus y squared equals 3. Hey, look. -2, -1, and 1, 2. Those are exactly the points that we said that they would be. Okay. Find the partial fraction decomposition of this. So we need to factor the denominator to do that. So this would factor as 10x minus 6 over x times, looks like x plus 3 times x minus 1. So the first step is to factor that. After we've factored that, we need to set up the form of our partial fraction decomposition. A over x plus b over x plus 3 plus c over x minus 1. Okay. We multiply both sides by our denominator. We get 10x minus 6 equals, we're going to need our full board for this, equals a times x plus 3 times x minus 1 plus b x times x minus 1 plus cx times x minus 3. Make the a look like an A if we can. Okay, from here, let's plug in convenient values for x. Like x equals 0 gives us -6 equals 3 times -1 times a. And that gives us a equals 2. Let's try plugging in x as 1. That gives us 10 minus 6 is 4 equals c times 1 times -2. So 1 times -2 is -2. -2 times c is -2c. That gives us c equals -2. And if we plug in, I guess -3 is next. -3 times 10 is -30. Minus 6 is -36. Equals -3 times -4 is +12. Times b gives us 12b, which means that b equals -3. So this means that our partial fraction decomposition is going to be 2 over x minus 2 over x minus 1 minus 3 over x plus 3. There's our answer. So that's probably easier than the ones that we did for the midterm, I think. Which I think is good. I think that the midterms should always be harder than the final, and the homework should always be harder than the midterms. So, no more questions. Let's move on. We're getting pretty close to the end. I think that if I don't get any other questions, then I'm going to stop the live stream when we get to the end. solve the system of equations by using the inverse of the coefficient matrix. So feel free to use whatever method you want. I know that the person who writes the test tries to like force students to solve things in certain ways. Um, this is how you solve it with the inverse coefficient matrix. So here's our coefficient matrix, 8, -5. I need a little bit more space. I'm just not that dexterous. 8, -5, 3, -2. We need to invert it. The formula is 1 over the determinant. Determinant is going to be -16 minus -15. So that gives us -16 plus 15, which is -1. So we have 1 over -1 times, we switch A and D, and we negate B and C. There's our inverse matrix. And 1 over -1 is -1, and multiplying -1 into this matrix gives us 2, -5, 3, -8. There's our inverse matrix with the multiplication performed. Now we're going to take that inverse matrix and multiply it by our constant matrix, 2, -5, 3, -8, times 3, -2. And that gives us 2 times 3 is 6, -5 times -2 is 10, 10 plus 16 is, 10 plus 6 is 16. That's our x value. 3 times 3 is 9, -8 times -2 is 16, 9 plus 16 is 25. So that's our y value. Mm, I mean, I kind of like doing the inverse matrix one, but you you can use whatever you want. Solve the system below using Gaussian or Gauss-Jordan elimination. Um, sure, we can do that. Um, so Gauss-Jordan elimination means we want to set this up as a matrix. So we have 1, 2, 4, 1, 2, 3, 5, 2, 0, 3, 10, and -1. So I have my 1 in the top left corner, so I just need to get zeros below it. I'll do -2 times the top plus the middle to get the new middle row. So I get -2 times 1 is -2, plus 2 is 0. -2 times 2 is -4, plus 3 is -1. -2 times 4 is -8, plus 5 is -3. -2 times 1 plus 2 is 0. Okay. Now I'm going to add 3 times the middle row to the old bottom row. So 0 times 3 plus 0 is 0. -1 times 3 plus 3 is 0. 3 times -3 is 9, plus 10 is 1. 3 times 0 is 0, plus -1 is -1. I'm now going to take -4 times the bottom row and add it to the top. These two don't change because the bottom row has 2 leading zeros. -4 times 1 plus 4 is 0. Um, sorry. -4 times 1 plus 4 is 0. -4 times -1 is +4 plus 1 is 5. that. I'm going to take 3 times the bottom row and add it to the middle row. Actually, I'm going to flip the sign on the middle row first. And then I'm going to subtract 3 times the bottom row from it. So that's a complicated enough one that I think I'm going to write it. Negative row 2 minus 3 times row 3. So the first two entries of the bottom row are 0, so they won't change what I do to the middle row. So I get 0 and 1. Then I go negative 3 times negative 1 is positive 3, and then minus 3 times 1 is negative 3. Positive 3 plus negative 3 is 0. Then I get 0 minus 1 times negative 3. So negative 1 times negative 3 is positive 3. 3 plus 0 is 3. Bottom row I'm going to leave alone. Top row, I do negative 2 times the middle row plus the top. That doesn't change because of the leading 0. That doesn't change because of the 0 beneath it. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 3 is negative 6 plus 5 is negative 1. That is my row reduced situation. So x is negative 1, y is 3, and z is also negative 1. A brick driveway has 40 rows of bricks. First row has 15, second has 20, and the remaining rows, each of the remaining rows has 5 more than the previous row. So we have I equals, we can do this a few different ways, but I'm going to say I equals 1 to 40. There are 40 rows of bricks. The first has 15, and each row has 5 more than before it. So 5 more than the row before it means we have a 5i plus something as our term in this series. 5 times 1 is 5. The first row is supposed to have 15 bricks. That's 10 more than 5. So now when I plug in 1, I get 5 times 1 is 5, plus 10 is 15. That gives us our first row of bricks. Having the 5 times the I means that every row will have 5 more than the previous, so this is the correct equation. Our binomial theorem is not our binomial theorem, our finite arithmetic series formula is this one here. That says that our sum is equal to the number of rows divided by 2 times the quantity of the number in the first row plus the number in the last row. So we do that. First row is when I is 1. That gives us 15 as we expected from the problem statement. The 40th row, 5 times 40 is 200, plus 10 is 210. We want to multiply that by the number of rows, which is 40, and divide by 2. So this gives us, let's just divide the 2 right now. 20 times 15 plus 110 is 225. 20 times 225 gives us 4500. That's how many bricks there are in the driveway in total. Okay. Find the coefficient of the term containing b to the 23rd for this binomial. So the binomial theorem says that the whole thing is equal to the sum from I equals 0 to 25 of 25 choose I times 3a to the I, sorry, not to the I, to the 25 minus I times b to the I. Turns out there are actually a couple of ways you could write this. There's a way you could do this where 3a would be raised to the I, but that's not how we did it. Oh, I need to change another thing. That b should look more like a b than a 6 for one thing. And two is it's negative b because we're subtracting b. Subtracting b is the same as adding negative b, so there's a negative sign that will go in there in the formula. So there's our formula. This quantity, the 25th power of 3a minus b, equals this. But we're only looking for when b equals 23, sorry, b is to the 23rd power. So we see that that happens when I is 23. So we're only looking for this particular term. Let's move this color thing over here out of the way. So we want 25 choose 23 because when I is 23, the power on b is 23. That gives us 3a to the 25 minus 23. That's just 2. And then we get negative b to the 23rd. Since it's an odd power, we get to keep a negative sign. And we get b to the 23rd. So this is the term we're looking for. 3 squared is 9. 25, choose 23 is going to be 25 factorial divided by 23 factorial times 2 factorial. Remember, the factorials on the bottom of the combinatoric have to like add up to the factorial in the numerator. So 2 plus 3 is 25. That's you can actually plug into the formula if you want. The formula's up here if you want to, but it'll come out to this. Whatever's on top over two different factorials that if you add what those not the value of the factorial, but what the argument of the factorials are, you'll get the numerator's argument. 3 squared is 9, so I'm just going to put a 9 right there. Then I get a squared. Get the 2 to look more 2y. A squared b to the 23rd. And then this problem requires us to get rid of the factorials. So 25 factorial over 23 factorial cancels to leave 25 times 24. Everything after 24 cancels with the 23 factorial. There's a 9 up here. On the bottom, you have 2 factorial, which just equals 2. 2 goes into 24 12 times, so I can cancel that there. Just get 1 in the denominator. A squared b to the 3. And just cleaning that up a little bit more, we get 25 times 12 times 9, a squared b to the 23. I should say 23 up there, like Michael Jordan. You can multiply further, but this is technically considered a complete solution for the test. You can leave it like that if you want. If you would like to go further, I kind of think that we can go a little bit further. 12 is 3 times 4, 4 times 25 is 100. 3 times 9 is 27. 27 times 100 is 2700. We get a squared b to the 23rd. So, I think it's nice to go further, but it's only nice in kind of a I'm curious way. not like I'm going to get more points if I do more way. In fact, if you do multiply out more, that's also more steps that you could get wrong. So, like, I would, for the purpose of the test, you probably just want to stop here with your factorials canceled out because that's required, but not going any further than getting rid of the fractions and the factorials because that's not required. And it's introducing more points where you could get an error. And that's the end of the test. See how it says simplify the answer as much as possible. The final answer should not contain factorials. Also, it shouldn't contain fractions. Okay. Are there any other questions from chat? Do we feel a lot better prepared for the test? I hope so. Let's see. We've been going for about an hour. So I hope that was useful. If we can go through the entire test, okay. I understand that when I look at these problems, I don't get stuck, and that students do get stuck on problems because they learned it this semester, not 20 years ago when they took the class like me. So I do understand that. But on the other hand, we did kind of slow down to explain some steps and to point out some potential errors. So if we could sit down and like explain the test in about an hour, it should be a test that we can take in about an hour, I think. I think that that seems reasonable. And the course coordinator is is both experienced and wise, and so I think that that should produce a good test as well. Best of luck to any of you. If anything, if you're watching this tomorrow or Wednesday morning and you have questions, please let me know. If you have other questions that are not from this, also let me know. I'll try and answer them before the test. I really wish you the best on this. Have a great day and good luck on the final. Bye.